CHEM152L. I hope you are all doing well during this very strange time. We're back with lab. It's online, so if we're back together, that means we got announcements. There's obviously a lot to catch up on. First, post-lab for experiment 5 was due. Many of you turned this in. However, some of you did not. That's okay. There is now an assignment in Canvas. Whether you're the Tuesday class or the Thursday class, you can see the due dates there. You now can upload the pages, take pictures of each page and upload for your assignment to turn in. Please note, as I emailed you before, it does need to be one PDF file that you upload, and then I can look at your pages and grade it there. All of you will be doing this for experiment 6. So again, one PDF file, and you can see experiment 6 will be due after spring break, either on April 7th for the Tuesday lab or April 9th. Please note, since we are moving online, schedules have changed, lots of things are different. The deadline is now the end of the day. So April 7th, Tuesday lab, your lab is due just before midnight on Tuesday, and Thursday just before midnight then. The exam 1 and practical still will happen. That will be after spring break, as talked about in class. That was going to cover experiments 1 through 6, and there'll be a portion to show hands-on. So clearly you'll be doing it online now instead of hands-on. But the review sheet basically is look at the 6 experiments. What are definitions, concepts, and equations? I will be holding office hours. That'll be from 12:30 to 1:30, Tuesday and Thursday. You can come to either office hour, doesn't matter which lab you're in, and this will be through Zoom. So I'll send you an email, and then there's an invitation to join the meeting, so you can do that online. Please note your lab assistants have committed to continuing to work. So Jamie with the Tuesday group, Kara with the Thursday group. The most visible way that you can see them is on these discussion boards. So go into Canvas, there's discussion boards. You can post questions on pre-lab, data observations, post-lab. More than likely, you'll get a quicker response during your lab time than other times, but they will be monitoring that. They will be responding to those, so I encourage you to use that discussion board. You can also note that grades have been posted on Canvas, so I'll continually post grades there, but some grades have been uploaded already. All right, so we've got announcements, and now, as usual, we've got outline. So you got a lab today. Well, what were the quiz questions coming? So remember thinking about what's this lab? What are questions that could be asked about this lab? That's a really important way to start going into this. If you take a look at the things that we're going to talk about here, would be great quiz questions. What are formulas? What kind of formulas are you aware of? Review is what kind of compounds have you seen so far? How can you name these compounds? So that's good review stuff, good questions leading up to this experiment. And this experiment is about calculating and determining an empirical formula. So that's a good definition. What is an empirical formula? We also have a review concept here. We're going to use the law of conservation of mass. So scientific method, talking about laws, that's going to come into play here as we talk about experiment 6. And the schedule, March 24th or 26th, depending on the Tuesday or Thursday, that's this week, that's experiment 6. Next week is spring break, so there's no experiment, and then we'll come back after that. All right, so let's get started. Well, to review, we can see that we've had things that we've been looking at and naming. So this first one, pretty standard ionic compound. It's made up of a metal, non-metal. We've even seen that in lab. That's sodium chloride. This one we know quite often. It's good to remember that this is a covalent or molecular compound. We call it water, of course, but we would name it the systematic way. It would be dihydrogen monoxide. So those are two different types of compounds. They have a different naming scheme, but the main thing is they have formulas to represent them. So that means there's 1 sodium and 1 chloride in this compound. In this case, there's 2 hydrogens and 1 oxygen. So if we take a look here, the formula is different of this compound by 1 oxygen. It now has 2. This is hydrogen peroxide. Different name, different formula, different properties. That's really key in thinking about formulas and compounds. And here we can get more and more complicated. This is glucose. It's not a systematic name, but this is the name for this C6H12O6. So this is, again, another covalent or molecular compound. There's no metals or ions in it. Same here with hydrogen peroxide. So this you've done. Well, now what we're going to look at in the lab is getting to empirical formulas. So that's the simplest whole number ratio, and in some cases, it's the same as the molecular formula. So sodium chloride, still 1-to-1 sodium to chloride. Water, that doesn't change. The empirical formula is still 2-to-1 hydrogen oxygen. Now we get to hydrogen peroxide though, and we see that the empirical formula, we divide by 2, and we get the ratio of 1 hydrogen to 1 oxygen. So then you can look at this one and think, what can I divide by? What's the lowest ratio? You could even pause if you want to take a few minutes, think about it. But what we can see is that if we divide by 6, we get the empirical formula of CH2O. So the empirical formulas, this column, is what this experiment is all about. You can do experiments and solve for the molecular. It just takes a little bit more data, a little bit more information, but you can still get this information. We're starting with the empirical. So what are the steps? What do you need to do? Well, depends on kind of where you're doing the assignment. If you do this in lecture, a lot of times you're given percents. So this compound was 20% carbon or 40% hydrogen. So if you're given percents, you need to get to grams. Remember, that's masses. To get to grams, and you have a compound, it's made up of 100% of something, so you can just assume 100 grams. So then if it says 20% carbon, then you have 20 grams of carbon, and so on. In lab, you need to measure these out. So you might weigh. That's how you can get grams. Weigh it. And you're going to see today a really important one also is by difference. If you have the weight of a couple of things, then you can get the weight that you need by subtracting. So trying to emphasize here, you either weigh it or you get it by difference. This is definitely a review topic from my lecture, is how do you get to moles if you're in grams? So we can look over here. If you're in grams, you're going to divide by the molar mass. So it depends on which element you have. Look it up on the periodic table. But it's always 1 mole, and then you look up how many grams. That gets you moles. Divide by the smallest. You put the mole number as subscripts. So you can put here, let's say I've got A, and then simple compound made up of 2 things, A, B here, and we don't know what it is. So you divide by the smallest moles. Maybe you then solve, and you ended up with A1, B 1.5. That takes us to our last point. We're not going to round. We need to get to a whole number, but in this case, it's really dangerous to round, especially some number like 1.5, when what you can do is multiply by 2 to now get the ratio that you're looking for. That's A2, B3. That's the correct empirical formula for this one. So then we can take a look what we're actually going to do theoretically in lab. So if you were going to do this, okay, first I say this is awesome. If you're burning magnesium, it is super bright. You can look up a video on it. You can see the video that I've given to you, but it doesn't replace seeing it in person. It's amazing. It's nice, bright, really impressive. You know, the awe of looking at fireworks. This is a similar, I would think, would happen if you did this. You've used Bunsen burners. In this case, we would use the Bunsen burners in the hoods. That would be really important. We've even had problems with the Bunsen burners getting so hot that they would crack the glass in the hood. So you'd have to be really careful with this. We use crucibles, and the video will show you a crucible, what that looks like. Please note, if we're talking about weight, we have to weigh things that are room temperature. If you have something hot, it definitely does not give a consistent weight. So that's a problem with that. So you want to make sure and weigh it before. Wait before it gets cool to room temperature, then weigh it. I say in lab, you just pull your hand next to it. If you can feel heat coming off, then it's not ready to weigh yet. The magnesium in the video, it shows you roll it into a nice loose coil. That shows that it can ignite and all the magnesium burns. If it's packed too tightly, it won't ignite all of it, and you'll have leftover magnesium, so that'll give you some mass problems. The process, you heat it up. It's very time consuming actually as well. You cool it. Then you're not done. You want to get rid of the nitride, so you add water, you heat it up, you cool. You're doing this hot, cold, because eventually you want to weigh the final compound. Okay, well, what are we talking about here? You start the magnesium, you weigh that, and then you burn it in the presence of oxygen, and it's bright, beautiful, it's fantastic. So you get the oxide compound. You weigh that. Remember, we talked about empirical formulas. You need grams. What you need grams of is you need grams of the elements. So in this case, you take the grams of the compound. That's the oxide. And you subtract the grams of the magnesium. You know that. And if you do that, now you know the grams of the oxygen. So we need the elements, grams of oxygen, grams of magnesium. Now you can figure out what you have for the empirical formula by going through those previous steps. So this is one part, burning magnesium. Second part is a little bit different. So this is solution chemistry. You're going to be collecting pure copper, which is really cool, looks really interesting. And you're going to use an evaporating dish to do that. The chemistry is pretty complex. It's a oxidation reduction reaction. You go from a copper solution to then a copper solid. You do use some nice lab techniques like decanting and then rinsing or washing the copper with hydrochloric acid, deionized water, and then lastly is acetone. This is a nail polish remover. It evaporates really easily, so you can get a nice weight of your copper. Looks a little bit different here. Okay, so we're weighing one element, that's the copper, but we need the chlorine, which is in the form of chloride. Well, we can get the total weight, just like we got last time. We weighed the magnesium oxide. In this case, we're calculating the total weight. So it's a little bit different, because if you take a look, the calculation involves concentration, which we haven't done yet. Okay, so the concentration is 1 gram per 100 mil. So what we have is, I'll give you an example with 15 mils. So 15 mils times 1 gram divided by 100, that gets us 0.150 grams of the compound. So now if I subtract grams of copper, then you can see I can get the grams of the chloride. If you got the grams of the chloride, or chlorine, you got the grams of the copper, then you can go back into the empirical steps and solve for the empirical formula. So this is a preview of the lab. I encourage you, go to the message board on Canvas, talk to your lab assistants, email me, or come to office hours through Zoom at 12:30, and we can talk more about it then.